Dear students, in the last class, we will discuss the basic concepts regarding software architecture, the meaning of software architecture, and what is the actual difference between software architecture and software design, and what are the different aspects that influence the software architecture, different architectural design patterns, as well as the architectural styles, as well as different 4 types of software architecture categories we have discussed. And in today's video we will start with the actual syllabus, that is module 1. The name of the module is what is a software architecture, what software architecture is, and what it is not. And the content is like this: what software architecture is and what it is not, and architectural structures and views, architectural patterns, what makes a good architecture, why software important, and technical context, project life cycle context, business context, professional context, regarding stakeholders, how is architecture influenced, what do architecture influence. These are the different aspects we are studying throughout this module. And the module 1 starts with a typical uninformative presentation of a software architecture. In this picture you can see the 4 different parts were there, and the first the part of this figure is at the top level, and the remaining 3 parts are at the below level. And this is called as a this kind of diagrams are called as a, that is acoustic simulation diagrams. And these kinds of diagrams are mainly used to simple out the natural frequency analysis for complex geometrics. And this kind of diagram, it is called as a top level architecture, because there are different level here. This level you can call it as a 0, and this level you can call it as a 1. At the level 0 there is a 1 element, and the level 1 there are 3 different elements. And you can see in this picture all elements are interconnected with each other, and they have named differently. And this top model, this top element, it is called as a control process CP, and the remaining 3 models are called as a prop loss model, reverb model, and noise model. And just seeing at this picture, we cannot predict what the actually figure represents, and what are the elements defined in this figure, what is their actual functionality, and how they behave, how they interact, or what is the interrelationship between them, it is undefined. And this system consists of mainly 4 elements, and the 3 elements are like this: prop loss model, reverb model, noise model. Might have more in common with each other than with the 4th, that is control process, because they are positions next to each other. All of the elements apparently have some sort of relationship with each other, since the diagram is fully connected. If there is no connection, it indicates that there is no interaction, or there is no interrelation between the elements. Here in the whole figure there is a connection between all elements, so they can interact each other and they can share the information each other. This is how we can predict the behavior of a structure. In this architecture, what can we not tell from the diagram? Here we cannot tell the nature of elements, that is what is the significance of their separation. Do they run on separate processes, or else do they run on separate times or at same times? Do the elements consist of processes, programs, or both? Processes means what is the processes means it is a collection of programs. Programs are a single attribute. Processes are multi attributes, and programs are a single attribute, or sometimes both. Also, it cannot represent, in which the project labor will be divided, whether all tasks will be handled by single element, or the tasks are evenly assigned between different elements. Do they convey the sense of runtime separation, or they exhibit their program at the same time? Are they objects, or else they are tasks, functions, processes, or distributed programs, or something else? All these elements, just by viewing the above diagram, we cannot define. Also, we cannot explain the responsibility of the elements. This is the second point. What is they do and what is their functions in the system. And next thing we cannot define the significance of elements. We cannot define the characteristics of the elements. Here you can see they are all the elements are interconnected with each other. There is an interrelation between the elements, but actually how they behave during a relation, whether they are they exchange information with each other, or they execute the program synchronously or asynchronously, or they hide some secret along with them and share the remaining information. Like this, many that is information we cannot predict from this single diagram. And synchronous behavior means that is at the same time. Asynchronous behavior means at the different time. Synchronous, the example for synchronous is when I make a call, the X person makes a calls to Y person. This is both are talking to each other. This is an example of synchronous behavior. And the example of asynchronous behavior is the X person send a message to Y, and the Y can view that particular message at a different time, or sometimes it may be same time. This is asynchronous communication. Like this, we cannot judge whether the elements are working in this constitute architecture synchronously or asynchronously. So these are aspects we cannot predict from this single picture: the nature of elements, the responsibility of the elements, and the significance of connection. Also, we cannot define what is the significance of layout. Here you can see four components are there, and the one component it is at a different level, and the other three components are at a different level. Means one at one other level and three at a different level. Means the group of elements are at a separate levels. And also we cannot define, does it call the other three elements, the top level elements, the control process may call to other three elements, or the others are not allowed to call it. Does it contain the three in the implementation itself, or they simply there is no room to put four elements on the same level, or on the same row of the diagram. All these kind of things we cannot predict from this single picture. So from this diagram does not show what is a software architecture. So to define a software architecture, we now define what does constitute a software architecture. The definition or the meaning is like this: the software architecture of a program or a computing system is a structure or a structures of the system. Means architecture of a program, it may be a multiple unit or it may be a single unit which comprise the software elements. Also the externally visible properties of those elements and the relationship among them. Some properties are visible and some properties are invisible. The properties like how to provide a security and privacy to the software, it is invisible, and externally visible properties like how to operate that the software and different guidelines will be provided. These are called as externally visible properties of the elements. Also we can see the relationship among them, how they interrelated with each other. So this is the actual definition given in the syllabus. Means software architecture of a program or a computing system is the structure or the structure of the system. Also from this definition we can say the system can and do compromise more than one structure, and we can tell every computing system must compromise elements. It is a combination of elements, it compromise of elements and the relations among them. And also we can define each structure consists of own behavior. All behavior constitute a functionality of a system. In this picture we have only 4 elements. Like this, it is a finite n number of elements, and all n number of elements behave differently. N number of elements is equal to n number of behaviors. Sometimes the behavior may be equal in some components, in some other components it may be different. So finally all the components consist of their own behavior. And finally you can tell software architecture in one word: it's a behavioral, it's a performance oriented, also it is a life cycle requirement mechanism. Next we move on to the further concepts of this chapter, that is other points of view. That is when we are studying the software architecture, we need to consider that is that is how commonality is inherent in the system. And the first thing about software architecture we can define is the software architecture is a high level design, and architecture is the overall structure of the system. And also we can define architecture is the structure of components of the program or a system and their relationships and principles, guidelines governing their design and evolution over time. And again the question arises, what is the meaning of high level designs? In a software designing there are three different styles of design: high level design, low level design, and the third classification is detailed level design. And the software architecture is a kind of design, and it is a high level design. And in the high level design, what it represents, what are the different types of parts involved in this. That is, high level design is a general system design, and it includes the description of the following parts: the description of the software architecture, or a description of the database design, or a brief mention of all the platforms, system services, processes the product would depend on. These all kinds of aspects come under a high level design. In this picture you can see before developing any software, these are the different levels the architect should consider. First, the architect will design the business requirement specification. In brief, you can call it as a BRS. And second, system requirement specification, that is the SRS. Third one is high level design. Fourth one is low level design. And next, after designing the high and low level designs, coding will start, and the last stage is software code. And during this, that is parallelly, they will test different aspects. In the BRS, they will test the acceptance of testing, whether the requirements are acceptable, whether the requirements of the stakeholders, the developer or architect or end user, customers, their requirements are feasible to implement really on the software. These all kinds of issues will be tested in the kind of testing called acceptance testing. We'll stop the video here, and next the steps I will continue in the next video.